Hi guys, this is Akhil, and today we are going to discuss about Amazon Redshift, which is one of the data warehouse service on the AWS. But before starting up with the Amazon Redshift, I would request you guys to subscribe our channel. You can find the link just below this video at the right side. So let's begin with Amazon Redshift, and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift. What do we mean by Amazon Redshift? The advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created you can define a specific virtual private cloud for your cluster, and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now the data warehouse cluster or each cluster has one or more databases in the form of a nodes. Now what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below examples show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage, we can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company. McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged in into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services. Click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now, to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte, or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2-node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something in with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor, and the query editor you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables. And then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it. And here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table, we'll be adding up the entries copied from the S3 bucket, and then move it to the Redshift database. And after that, we'll query the results in the sales table. Now, whatever the values you are creating in the table, the same values needs to be in the data file. And I have taken up this sample data file from this link, which is docs.aws.amazon.com, Redshift, sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales_tab.txt is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now, after putting up the command for creating up the table, then we'll use a copy command. And copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now, path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales_tab.txt file. Also, we have to define the role ARN that was created previously. And once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have 2 T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name, Redshift bucket sample. Let's copy that, put it here, connect to the window, connect back to the database. Right, and now execute it. So table sales created. The data in the table has been copied from the S3 bucket to sales_tab.txt to the Redshift, and then the query of the results. The results from the table has been queried. So that's it with respect to the Redshift perspective, and I hope you liked our video. Just don't forget to subscribe and like our channel. Watch out for our channel for the upcoming videos on the AWS itself. Bye for now. Thank you.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.